Hi girls, I'm just going to bring you a short lesson continuing from where we left off on Friday. So on Friday's lesson, just to remind you, we did a few experiments using lenses. So we looked at the lens and tried to focus the image of a distant object on the screen, and then we did some experiments with candles and we saw how an upside down image is formed of the candle is formed on a screen. So the next step is to tell you how to draw ray diagrams with lenses. And in order to draw a ray diagram, just like we did with mirrors, we have certain rules. Now, for lenses, we're just going to look at two rules. And for the first rule is this one here. So we draw a set of perpendicular axes, and the horizontal line represents the principal axis. The vertical line passes through the center of the lens. Where both these lines intersect is your optic center. Now, because a lens, light can travel through it, you can put the object on either side. So a lens essentially has two focal points, one on each side, and this one is 2f. That represents the C in the mirror, but we don't call it C for the lens, we just call it twice focal length. So you've got them on both sides, equidistant. Okay, so the first rule is any ray going through the optic center will carry on along the same path. So that's quite an easy one to remember. You just draw one line. Okay, and it goes through the other side of the lens. And then the second one is any ray that is parallel to the principal axis will go through the focal point. It actually goes through the focal point for a convex lens, so it's got a real focal point. But for a concave lens, which is a diverging lens, that means it gets the ray spreading out when it goes through the lens. So it appears to come from the focal point. Okay, so a concave lens has a virtual focal length. It has a virtual focal point. And I'll draw a whole set of ray diagrams just like we did for mirrors. And the ray diagrams are keeping the object at different distances from the lens. So we start with the object beyond 2f, the object at 2f, the object between f and 2f, the object at f, and then the object between the lens and f. So there's a whole set of ray diagrams which I'll draw and I'll post for you so that you can take that down in your notes. So once we're done drawing ray diagrams, the other thing that I would like to teach you is the lens formula, and that is the very last thing under light. So for the lens formula, we use exactly the same rules as we did with mirrors. So the first thing is real is positive, virtual is negative, and all distances are measured from the optic center. And the formula is exactly the same two formula, 1 over di plus 1 over do equals 1 over f, and magnification is di by do equals hi by ho, where di is the distance of the image from the lens, do the distance of the object from the lens, f is the focal length, and h is the height of the image, height of the object, and m is magnification. And remember, all distances from the optic center. Okay, so I'll write down some notes, and this is actually a video of the content for the last two lessons, and so you can take today and tomorrow to do this, and the lesson that follows this, once you work through the questions, the lesson after this for this week is to do your assignment, and I'll post the assignment answers because I didn't really have time to hand out the papers to you because we didn't meet at all on Monday. Okay, so take care, be safe, and bye for now.